Hi, I'm Khalil and I'll help you solve question 19 on page 377 in the Nelson Advanced Functions textbook. Question 19 states that a person's blood pressure, P of t, is measured in millimeters of mercury and is modeled by the function below. Before answering any questions, you must try to find which units and lessons the question originates from. This question derives from Unit 4, Sinusoidal Equations. Recall from question 19 that a person's blood pressure, P of t, in millimeters of mercury is modeled in the function below. P of t is the person's blood pressure based on a given time. mmHg is the units used to measure the blood pressure, and where t is measured in seconds. Question 19 is split up into 4 parts. What is the period of the function? What does the value of the period mean in this situation? Calculate the average rate of change in a person's blood pressure on the interval of 0.2 to 0.3 and estimate the instantaneous rate of change in a person's blood pressure at t equals 0.5. These questions require finding the period of a sinusoidal equation, the ability to use givens to understand what the period means in this question, and grade 11 knowledge of AROC and IROC. Before making any calculations, make sure you are in radian mode on your calculator. Part A. What is the period of the function? To find the period of the function, you must first find the b value of the equation. In this case, it is 8 pi over 3. After finding the b value in the equation, you must divide 2 pi by the b value to find the period. In this case, you must divide 2 pi by 8 pi over 3, and dividing a number by a fraction is equivalent to multiplying a number by a denominator's reciprocal. So 2 pi times 3 over 8 equals 6 pi over 8 pi. After having 6 pi over 8, you must cross out the pi's from the numerator and the denominator and then reduce the fraction from 6 over 8 to 3 over 4. Part B. What does the value of the period mean in this situation? Therefore, the period equals 3 over 4 seconds. The period equals 3 over 4 seconds. The period equals the measurement of heart rate. The time it takes between one heartbeat and the next equals 3 over 4 seconds. Thus, it beats every 3 over 4 seconds and 80 beats per minute. Part C. Calculate the average rate of change in a person's blood pressure on the interval 0.2 to 0.3 seconds. The two equations you must use for this question is first the blood pressure equation, secondly the AROC equation. You must plug in 0.2 and 0.3 into the blood pressure equation once at a time. After finding the blood pressure of 0.2 and 0.3, you must plug it into the AROC equation. To find the blood pressure of each unit, you must simply just plug it into a calculator. calculate the average rate of change, you must calculate the number in the denominator and numerator, then divide and round the number to the first whole number. Therefore, the average rate of change between the interval 0.2 and 0.3 is approximately 141. Part D. Estimate the instantaneous rate of change in a person's blood pressure at t equals 0.5. For this question, you must use the blood pressure equation and the IROC equation. First, you must plug 0.501 and 0.499 into the blood pressure equation, once at a time, similar to Part C. To find the blood pressure of each unit, you must simply just plug it into your calculator. After you find the blood pressures, you must use the instantaneous rate of change equation. You first calculate the number in the numerator and denominator before dividing. After dividing, you round to the first whole number. Therefore, the instantaneous rate of change when the time is 0.5 is approximately negative 145. I believe this question relates to a heart surgeon. A heart surgeon must know when their patient's heart is beating too slow, too fast, or at the regular pace. With the help of heart rate monitors that measures how many beats per second a heart makes, the heart surgeon knows when to make the next move. Realistically, knowing someone's heart rate can be the difference between life and death.